Welcome to this video on how to prove triangles are congruent. This is part 2 of a 3-part lesson. This lesson covers the most common properties, definitions, and theorems for triangles. In the last video, we looked at the 4 patterns of triangle congruence. Here we'll look at properties, definitions, and theorems for triangles, and in the next video we'll look at how to develop and write the proof. So why are these theorems important? We've looked at 4 ways to show that triangles are congruent. They can be summarized as SSS, side, 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 SAS, side, angle, side, ASA, angle, side, angle, and AAS, angle, angle, side. We also learned that you cannot show congruence with either of the following patterns: AAA, angle, 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 or SSA, side, side, angle. But how do we know whether sides or angles are congruent? Every problem will give us some information that we call given information. Using the given information, we have to be able to reason out other facts about the triangles. We can use the information from this lesson to help us figure out more information about our triangles. So let's get started. The first technique is the reflexive property. Line segment AB equals line segment BA. If 2 triangles share a side or an angle, then that side or angle is congruent in the 2 shapes. For example, here's an example of a property of this property where the triangles share a side in common. So you see a shape here, and one of the things that you should be able to tell is that this is 2 triangles put together. If we separate them into HKJ and IJK, you can see that these triangles shared HJ in common, and therefore the side HJ is obviously the same length, so those sides are congruent. Here's an example where the triangles share an angle in common. Here you see 2 triangles overlaid on top of each other. If we separate the 2 triangles, we can see that the angle that they shared was identical and therefore is congruent. So that's some examples of the reflexive property. The next one is that vertical angles are congruent. When 2 straight lines cross, the vertical or opposite angles formed are congruent. So for example, here are 2 lines which cross, and I've labeled the angles as A, B, C, and D. According to this theorem, angle A and angle C, which are vertical angles, and angle B and angle D, which are opposite angles, are both equal, are both congruent. So that's another way we can find out more information about triangles if they are made from lines that intersect. The next one is that right angles are congruent. This may sound obvious, but when you are given right triangles or squares or rectangles, you know that the right angles are congruent. In the diagram below, there are several triangles. Angles B and E may look like right angles, but we can't be sure unless we're given that information specifically. If you're told that the triangles ABC and AED are right triangles, or if the right triangle symbol appears in the diagram, then you know that angle B and angle E are 90 degrees and are therefore congruent. The next one is that alternate interior angles of parallel lines are congruent. When the givens inform you that 2 lines are parallel and there is a transversal line, you can conclude that alternate interior angles are congruent. In the diagram below, for example, if you are told that the sides FG and JH are parallel, then you can tell that JG is a transversal between them. From what you learned about transversals earlier in the course, you know that alternate interior angles, like the ones shown in red below, are congruent. So once again, if you know that 2 lines are parallel and there's a transversal, you can use that to conclude additional information about the triangles involved. The next one is a segment bisector. If you are given that a line bisects a line segment, then you know that the 2 halves of the bisected line are equal. The word bisect means to not only intersect a line, but cut it into 2 equal parts. So in the diagram below, if you are told that line L, the vertical, almost vertical line here, bisects line RT at point Q, then you can conclude that the sides TQ and QR of those respective triangles are congruent. This gives you at least one side of your triangles that is congruent. Note that in this particular example, you can also see that because these two lines, NS and RT, intersect, you also have opposite angles that are congruent. So you actually have a side and an angle. But that's a segment bisector technique. The next one is the definition of a midpoint. Midpoint obviously is the center of a line. If you are given the midpoint of a line, then you know that the segments on both sides of the midpoint are congruent. So for example, in the diagram below, if you are told that point J is the midpoint of line segment KI, then you know that the length of KJ is equal to the length of JI, and that those two line segments are congruent. In this particular example, you do not necessarily know that the angles KJH or IJH are right angles, even though they appear to be. All you know is that J is the midpoint of this line, and therefore those two line segments are congruent. The next one is the definition of a segment bisector. If you know that a line bisects another line, you know that the segments on both sides of the intersection are equal. In the diagram below, if you are told that line L bisects line RT at point Q, then you can conclude that TQ and QR are congruent. Once again, you can also see that the opposite angles NQT and RQS are congruent. But the main message of this technique is that if you have a segment bisector, the line that is bisected is broken into two congruent halves. Next one is a definition of an angle bisector. If you are given that a line or line segment is an angle bisector, then you know that the two parts of the angle are congruent. So in the diagram below, if you are given that DH is the angle bisector of BDF, then you know that angle BDH and angle HDF, shown in red, are congruent. The next one is similar to the definition of a bisector, an angle bisector, but it is a definition of a perpendicular bisector. A perpendicular bisector creates two right angles and divides a line in equal halves. For example, in the diagram below, if you're given triangle RST and also given that line segment RX is a perpendicular bisector of side ST, then you know that line segments TX and XS are congruent, and that the two angles shown below are both right angles and therefore congruent. If you're able to use this theorem, then you can get both a side and an angle out of it for your effort to prove one of the four methods of congruence. The next item is the third angle theorem. If two angles and two triangles are congruent, then the third pair of angles is also congruent. In the diagram below, you're given that angle A and angle D in the respective triangles are congruent, and angle C and angle F are also congruent. When we have a single line for an angle, we're saying that any angles with that single line there are congruent, and when you have a double line, you see that you're being told that any angles with a double line like this in blue are also congruent. They're not the same as the single line angles, but they are equal to each other. If you're given two angles in a triangle that are congruent to two other angles in another triangle, then since all of the angles in any triangle have to add up to 180 degrees, then angle B and angle E must also be congruent. Note that angle, 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 which this shows, does not prove that the triangles are congruent, because you could have similar triangles where one is larger than the other, but they still have the same, their angles are still the same size. Still, it's helpful to be able to identify this additional information when you see that two angles are equal between two triangles. So that was the most common properties, definitions, and theorems for triangles. I hope you find this useful, and in the next video we'll see how to construct a proof using this information to prove that triangles are congruent. Thank you for watching this video. Leave your comments below, and if you haven't subscribed already, please subscribe.